So I'm Tony. I want to talk about X402. If you read the white paper for X402, it was built for payments for basically agents on the web, and it also revives a old HTTP protocol. So if you think about like 400 or 404 in terms of like error signs when you come across a website that's not found or you don't have permissions for. 402 uses the existing web infrastructure, and I think that's the beauty of it. It's very simple. There's a payment request that is required to essentially access an API. So right now, if you actually sign up for a API, I think most of you guys know it does take some time for a human being to do that. Whether it's setting up a billing account, storing your credit card, you know, simplifies it for X402 is that agents don't need to do that anymore. Agents can just simply provide the payment because, from a cryptographic point of view, that token has transferred across and settled on the blockchain. And then the API response from the server can be provided to the client. And I'll go a bit more into, I guess, the applications for this, but I think really is that credit cards don't really fit because if it's like or 5 cents per transaction, or if you think about some of these inference calls where it could be like 3 cents per image or much less. For other services, credit card with their fees don't really work. And essentially, you abstract away the account APIs, you remove some of the middleman costs of cards, and you allow agents to actually, browse the web for different tools and pay for them using stablecoins. X402, what is it? An open payment protocol, so anyone can really essentially use it. That really leverages a HTTP 402 existing Web 2 infrastructure in order to charge for a set amount of stablecoins without using any account setup, no API key, and no session. So as long as you provide the stablecoin and we verify and settle that stablecoin on the blockchain network, we can provide the API response. This has been, seeing, I guess, tremendous success. So if you see on the right-hand side, when it was first launched, you know, we are seeing about 160 million in transactions, $48 million in volume, and 140,000 agents on ERC 8004. I'll bet like a lot of these tools right now have been for trading, or a lot of the agents on ERC 8004 don't really, I'd say, don't do anything. So we're still in the nascent stages of the game right now. But I think if you look around the industry, like for example, I think it was Stripe. Yeah. So I think Stripe launched a machine payment protocol. So they have like an easier on ramp and off ramp. But that in itself, I think, is still in testnet as well. So we're coming up to, some of the early stage indications that this could be useful. And especially with like OpenClaw, we see a lot of skills being launched on the marketplace. Like I think in the future, like besides the payment of premium APIs, potentially we will have, you know, payment to actual vendor items as well. So like, let's just say e-commerce, you pay for an item, like it wouldn't just be for the inference call or for the specialized compute, it'd be for stable coins for settling the transaction as well. So, they call it machine to machine and machine to vendor. Like I think there's different applications there as well. So on a high level, really, you have a client, right? Which is really, it could be humans. Like you see some applications like on the demo on the 402.org, like they have a simple call of an API, like a human, you can press it for settlement on whatever base Apolia, and that gives you an API response. But I think it's really built for agents. So in the sense that, the agent will call it, the resource server will say, you have to pay for a payment required with the payment instructions. The client on your side, so basically, let's just say you're the human, you see the payment request instructions, you basically sign it, and then that signature will not require any gas because you have verified that you've signed the signature, and then the server will forward that signature to the facilitator, and because you have signed it, basically they would generally sponsor the gas fees and package that transaction and settle on the blockchain. So it's beautiful in the sense that you're actually sending a stable coin without using gas, basically, right? So you're making a transaction without gas, and the facilitator will pay for that gas because under the stablecoin, and then Complex has two stablecoins which are that can facilitate this. There's functions to basically require the signature from the client and settle that transaction. So I'll go a bit more detail a bit in the code on what happens, but this is really the flow is really, the client signs or requests for a response, and then the resource server will say, oh, you need to pay for 402. Then the client will sign the payment load based on the 402 payment requirements. So it says whatever, 10 cents is needed. You have to sign at 10 cents. The resource server sends it to a facilitator on the right. So it calls, for example, two API endpoints where it's verify and settle. They'll settle the transaction, and then the resource server will provide the API response to the client. So this is a snapshot from the white paper. Basically, it's basically how this works right now. As I mentioned before, you can go into this a bit more, but like I think we can go into the details of the code. I think that kind of walks through the payment flow. But essentially, the header is sent across from the server. The server to the client sends the payment require, and then the client sends back the header, which includes basically a signature of the payment. Basically, on Complex, there's two stable coins which allow you to essentially use different functions to sign for the transfer with authorization and receive with authorizations, were the most common ones that are used. And with that, you're able to send the transaction without using gas. So USDT 0 is something that we recently launched on Complex eSpace. Basically, it is a derivative of the USDT that has a transfer with authorization and also receive with authorization inside the write function. So if you look at the contract itself, and also AXCNH, that also has that too. So the EIP 712 domain is a little different in terms of version between the two. So that's something that you can note when you package the signature. These are two stablecoins that you can use for implementing the x402. So in a bit more detail, this might be a little bit more clear to understand what's going on here. So you have two stable coins. You have the details of it. The EIP 712, which basically identifies what the name and the version is. And on the bottom here is basically you are essentially specifying what you need from the client. So as a server, let's just say you set up an API endpoint. You say when someone requests for your services, you'll say you need to pay to what receiving wallet. So who's the person providing the API service? What is our endpoint? So let's just say this is the weather endpoint. And then here is the specifications here where, the network would be complex eSpace, and you accept, whatever, 1,000 USDT 0 in essentially 6 decimal points. That would be like 0.001 USDT or AXCNH. So you can accept either or. And then you provide the facilitator basically endpoint, which helps essentially process the transaction. So this is from, I guess, the server side. And then from the buyer side or from the agent side, you basically, you see this typical, this looks like something like Ether where you're setting up the wallet client. And from there, you basically, at the bottom here, sign a EIP 3009 on the 402. So the server sends the 402 request, and then the client will say, oh, we will actually sign the EIP to meet the exact specifications of what is needed to get the API response. So from there, basically, we set up our connection to the blockchain, and we send the signed transaction. But what is that actually that you're signing, right? So what are you actually signing? On the left-hand side, what you're actually signing is, basically a payment schema, where on the right-hand side, you are sending back to the server the domain, which is basically the asset. So you're saying we're going to pay in AXCNH version 2 on chain ID 1030, which is complex eSpace, with the token address of AXCNH. And then the way we're going to do it is receive with authorization, which is a function. We'll go a bit into detail a bit more what that is and the difference between transfer with authorization and receive with authorization. But the type here is really, you can see this ABI is basically, from us as the agent or the consumer of the API to basically the API provider, which is basically the seller of the API, the value, which is exactly what is needed, and valid after and valid for before. So you want to specify how long this transaction is valid for before it's processed, and basically a nonce to make sure that it is not duplicated. So you have this transaction in the ethers, allowing for anyone to really package it. So it doesn't have to be the facilitator that packages the transaction, but it is sent as a signed signature into the facilitator, and from there the facilitator can either package it with other transactions to settle, or settle immediately and pay for the gas fees as well. But basically, as you can tell, like, it's just basically instructions that you're signing from the wallet side. So if you see wallet.sign typed on the right hand side here, you're signing the type data and then allowing the facilitator to basically settle that transaction. So right now we're seeing, basically, if we just step back a bit, we're really seeing payment between a payment and stablecoins, done in a way which is gasless, but also is cryptographically secure. The magic here is, like, if you go to the basically the two tokens, USDT zero and AXCH, and look at their functions on the conflict scan, you'll see that they have transfer with authorization and receive with authorization. The transfer authorization is really, we will push to the recipient. So as a facilitator, like, we have the ability to settle that transaction, right? But receive with authorization is, if you're the buyer, you can call, it has to be called by the person that is selling it to you. So must be called by the two addresses. See on the right hand side. So in order for the stable coins to land to the person that is selling the API, they have to be the one that calls it. So this has different implications on basically what kind of functions you have. For example, let's just say escrow or refunds. In receive with authorization, let's just say, the seller is willing to be the one that actually basically waits for them to call before they receive it. And the transfer authorization is basically anyone. Basically, it could be me, it could be the facilitator, the relayer, or even the seller themselves. They can actually push it to fulfill the transaction. So right now, I think, if you look at 402scan.org, across mostly base, we're seeing, about 166 million transactions on 47.4 million volume to date. So that's, about 30 cents per transaction. And I think, what that means is, like, we are still seeing a lot of microtransactions. So, a lot of the early promises of x402 would be something like, let's just say if you wanted to access a song or a picture or something like that, or access like trading information, these would be more on a pay per use standpoint. So if there's no subscription, so on the right hand side, it could be something like, fetch a proprietary data set and so on and so forth. But I think in the white paper itself, like, it talks about, like, let's just say an agent that wants to set up, its own website, or scrape the website for somewhere or use a tool. That's where, some of the interesting unlock could be as well. But there are some interesting use cases, I think, for accessing resources that are on a pay per call basis, because I think, inference calls, as are generally micropayments as well. So really, in summary, like, the X402 is, it aggregates the actions needed. So, typically, even as a user itself, it moves from, like, 5 steps to maybe like 3 steps, where you don't need an API key, you don't need, like, to set up a billing account. But the most important thing is, you don't need to have, like, 50 million API keys to access like 50 million different resources. And as we see, like, the explosion of agents here, where you're going to have a lot more agents than humans potentially browsing the web. This makes sense, right? Like, you're going to have a lot of tools that agents will kind of look at. We're seeing a lot of, like, skill marketplaces, a lot of different MCPs as well. And so the 402 is basically, you can think of it almost like a wrapper to access different, tools. Some of the places that people talked about, is like article paywalls. So, and it's been hard for newspapers to kind of charge But you can have a lot of creative elements to it. Maybe it's like a charge per time, charge per word, I don't know, charge per click kind of thing. You could be like charging for people liking or providing a review. Like, so there's a lot more like micropayments that potentially can happen to incentivize different business models. Two marketplaces, I think that's super interesting. Basically, with the explosion of OpenClaw and things like that, where we're seeing, for example, Google building MCP compatible websites, so agents can browse that as well. You can see like Shopify has their agent, you know, unified commerce protocol where people can purchase, products on ChatGPT. So I think there's a lot of interesting use cases, not just from a tool marketplace, but other applications from a actual commerce standpoint. And then on-demand compute. So I think given like if you think on a decentralized element standpoint, if people can now essentially have really powerful local LLM models without using API calls. They can provide API responses themselves, right? So they can download Quen and provide that as a service, or download Comfy UI and set up a workflow for people to build image generation. So there's really interesting applications there as well. We're also seeing some evolution on different SDKs. So the most common one is the exact one, which is the most stable production, where it requests for a specific stablecoin. But yeah, like I think if you go around in itself, there are libraries that help you build the wrapper basically, including the facilitator. Like you can just look at the open source facilitator. You can host it yourself. You don't need to look for a public one, especially since Conflux eSpace is very, very low gas fees. So where does X402 go next? I think right now it leverages the existing 402 HTML Web 2 infrastructure. So in a sense, it's not like I'd say like it's not like astounding technology in itself. I think it's powerful in the sense that there's a lot of things that you can build on top of it in terms of applications itself. And some of the things that have still been looking to be improved on is for example, transaction bundling, right? So let's just say, for example, Ethereum, if the average transaction size is zero point 0.3 and each transaction you need to pay 30 cents in gas fees, ruin the economics a little bit when you can charge 30 cents instead of 60 cents or a dollar, right? So from there, like I think transaction bundling does become a little bit more important, where essentially you can think of ways to batch transactions, program escrow and refunds. So I think like you know when we think about like I guess this kind of even goes back into like even the wallet issue. So if you're having like a server or facilitator or things like that, where you basically have keys in itself, there's a whole, I guess, section of how do we make it such that we can separate the agent keys from the server itself, or how do we make sure that we can provide refunds when the API response is not good, or from a proof of compute standpoint, like how do we ensure that the agent, which is registered, maybe let's just say so something like 8004, which is like NFT of like the different agents on Ethereum or Base, for example, and they say one thing, but like maybe they're not using, Seed Dream 2.0, maybe they're using Kling AI to generate the video. How do we prove that the AI or the server hasn't been tampered with, right? Is it like is a hash of the Docker? Is it like, what is it is provable to ensure that, that API endpoint is not changed? So there's a lot of different areas here, whether it's like, streamable payments. So, it's not like a call per payment. It's like, you authorize and it pays, over time, or, it helps provide an escrow where if you're doing e-commerce, then, that payment doesn't get sent until like whatever 24 hours later. So yeah, that's really, what X402 is. And I think in this hackathon, like we do have stable coins that are compatible with X402. And because we are, basically, Ethereum based type network, we can essentially do anything that is able to be done right now in some of the other networks. So I think there's a lot of ability here to, look at, from a creative element, like whether it's, some of the things with AXCNH or USDT zero. I think there's a lot of applications here. So if you go to the complex e-space scan, right? So you'll see the AXCNH and USDT zero. These would be the ones that would be compatible. It's not the US Tether USDT. So these ones both, if you look at their contract here, you can see like there's the receive with authorization and transfer with authorization. So basically these are the specifications that you would request for and be signed on the header. So, and then yeah, like I think if you were to look at like x402.org, they have like the basic documentation of like how you would actually write the or just basically import the library. Like it's very, very simple. Like you just have um like a quick start for sellers and buyers. Like that can be basically applied to Conflux, but you just have to specify that Conflux would be the network, and the EIP domain of the actual token. So you just have the right name in terms of whatever AXNH, token address, and as well as the version. So I think those would be great places to start. And if you have any questions on X402, feel free to drop it in the Discord or in the Telegram, and we can kind of follow up on that as well. Great. Yeah. Thanks, guys. Thanks for attending. Appreciate you guys all your time.